In this video, we're going to be going over equivalent expressions or combining like terms, and this is VL-1035. So let's begin. So this is an example of an algebraic expression, 2x squared plus 9x minus 1. Now, this is a term. 2x squared is a term, and 9x is also a term, and 1, or negative 1, is also a term. Now, a couple other things we should know about this. One right here, this is also known as a coefficient. Sorry, not a coefficient. What am I thinking? One's also known as a constant because it's a number that's by itself. It's not being multiplied by a variable. And then two more things we should know, which is the 2 right here, the 9. Those are known as coefficients. And coefficient. So that would be the 2. That's also the 9. And coefficients are the numbers that you multiply a variable by, or it's like the number in front of a variable. Let's go ahead and start off with some vocab. So, an algebraic expression. An algebraic expression is an expression that contains a variable. So, variable. So what's an example of an algebraic expression? How about n plus 1? That's an algebraic expression. Or you can say like 2x squared plus 5x minus 4. That's an algebraic expression because it's an expression with a variable. What is a variable then? Well, a variable is a symbol, usually a letter, that represents an unknown number. So an unknown number that can change. So in the example below, 3n squared plus 5n plus 10, what's the variable? Well, it's just the n. So if you have a highlighter, you can highlight that, or you can just circle. Oh, it's the n. All right, what is a constant? A constant is a number that doesn't blank. It doesn't change. Also, it's known as a term with no blank attached. It's a term with no variable attached to it. So what are my constants? I only have one constant in this example, 3n squared plus 5n plus 10. My only constant is the 10. And to be technical, probably should include the plus in front of it, but don't worry about it for now. Term. Now, term is a really complicated vocabulary word because, well, it gets really complicated. But to keep it simple, a term is the parts of an expression that are blank or blank, parts of an expression that are added or subtracted. Like I said, it could get more complicated than this, but we're just going to keep it simple. So, what are my terms here? They are 3n squared, they're 5n, and they're 10. So, this is a term, this is a term, and this is a term. So what are terms? They're separated by pluses and minuses, to keep it simple. There's more to it than that, but this is a good enough definition for right now. What is a coefficient? A coefficient is a number that is blanked by the variable in an algebraic expression. It's a number that is multiplied by the variable in an algebraic expression. So in this case, what is the coefficient? We have two of them. It's 3 and the 5. So another way to think about a coefficient is it's the number in front of a variable. And what do you do with 3 and n squared? Well, if you knew what n squared was, you would multiply that. And if you knew what n was, you would multiply 5 times whatever n is. And finally, this is actually the most important vocab term for today's lesson, like terms. Like terms are terms with the same blank to the same blank. They are terms with the same variable to the same power. So, let's come up with a couple examples. 5n plus 2n. This is an n, this is an n. They're both like terms because this is an n and this is an n. What I can do later is I can combine those two. Let's do another example. 3y square, or to the second power, plus 5 or 6y square. These are both like terms because they both are y's, same variable, and it's to the same power. Let's do one more example of like terms. 1 plus 2. Both of these are like terms, 1 and 2. They're both like terms because neither of them have variables, which means we can actually combine them. So let's do some examples of terms that are not like. Not like terms, how about 3a plus 4b. Why aren't these like terms? Well, because this is an a term and this term has a b next to it, and we can't combine those two. Let's do another example. 5n plus 6n to the third power. How about 5n squared plus 6n to the third power? Why aren't these like terms? This is an n, and this is also an n. It's because they need to be to the same power. So you can't combine them, and we'll talk about what that means to combine them later. But yeah, like terms are like, you have an n here, you have an n here, 5n and 2n, you can actually combine those, y square, no variable, they are like terms, you can combine them. So we've got two examples. We're just, these are just, we're looking at vocab. So what are my terms here? Well, if I want to look at my terms, let's take a look. We have my terms are 5y squared plus y minus 2 minus 3y plus 4 minus 7y squared. What are my terms? My terms are 5y squared. I also have y. I also have 2. So this is a term, and this, and this, and this, and this, and this. And 3y, and 4, and 7y squared. Now, if I want to be technical, if there's a minus in front of it, I should technically say, actually, that's a negative 2. Like this minus this 3y right here, there's a minus in front of it, so I really should call this minus 3y or negative 3y. And this is technically negative 7y squared. It's not super important for you to understand right that. And you may be thinking, should I have put a plus or a positive in front of the other ones? You don't have to, because we assume if there's no sign in front of it, it's positive. But yeah, those are your terms. We have 1, 2, 3, 4, 5, 6. They're separated by the pluses and minuses. All right, what are the coefficients? Well, my coefficients are the numbers that multiply the variables, so the 5 and the 3, technically it's a negative 3, and also a negative 7. And there's actually one more hidden coefficient here. So it's 5, and then 3, or negative 3, and then negative 7 technically. And there's technically one more hidden coefficient. It's next to this y right here. What is the number that's in front of the y? Well, it's technically a hidden 1, like a 1 right there. So so we actually have 4 coefficients, 5, 1, negative 3, and negative 7, so 4 coefficients. And finally, like terms. Like terms, do we have any pairs of like terms? Well, let's see, we have 5y squared. Anything go with 5y squared? Well, yeah, this 7y squared, so it's 5y squared and negative 7y squared. Any other like terms? Well, let's use a different color. Is there anything that goes with the y? Yeah, this one, 3y, or technically negative 3y. So let's do, we have y and negative 3y. And finally, any other pairs of like terms? We've got this 2 and this 4, or actually technically it's negative 2. So yeah, those are my like terms. You can try this one, the next set, on your own. My terms are, let's start with, let's do purple. We've got n to the second power. We've got 3n, or technically it's a negative 3n. We've also got 2, or a negative 2. We've also technically got negative 5n, and also 10. Those are my terms. What are my coefficients? Well, I do have like a secret hidden one over there. So there's one of them. It's also this, in front of the n is 3 or -3, and also this -5. So my coefficients are like 1, -3, and also -5. And if I asked you for what the like terms were, what are my like terms? Well, I've got, start with the first one. Any n squares? Actually, there are no n squares, so no like terms that go with n square. How about 3n? Anything that goes with 3n or -3n? Ah, yes, 5n, so let's do that in blue. -3n and -5n are like terms. Let's see. Anything that goes with the 2 over here, the -2? Yep, 2 and 10. So -2 and 10 are also like terms. Let's go to the next page. So this is where we are going to get to the, we spent a lot of time on vocabulary, so hopefully you remember a lot of it. The biggest thing we need to know is like terms, because we're going to focus on like terms and we're going to combine them. So on the next page, it says Jax was at Burger Queen ordering food for 2 of his friends. His friends were texting each other, his friends were texting him their orders while he was in line. The first friend texted that they wanted 5 burgers, 2 fries, and 4 drinks. The second friend texted that they wanted 3 burgers and a drink. Then the first friend texted again and asked Jax to take off 2 burgers and 2 drinks from their order. If a mathematician wrote a mathematical expression for this story, what would they write down? Well, they would write down 5b plus 2f plus 4d plus 3b plus d minus 2b minus 2d, which sounds really complicated. You may be thinking like, wait a minute, that sounds really crazy. It's not as bad as you think. It's asking us, can we simplify the mathematical expression and explain what it means? Well, let's talk about what this means. Well, what is 5b? Why would a mathematician write 5b? Well, the first friend needed 5 burgers, right? So 5 burgers, 5b. The first friend also wanted 2 fries, so you would add 2 fries, right? 2f is the 2 fries from the first friend, plus the 4 drinks, and so they said, oh, that's 4 drinks, 4d. Use different variables for the different things. And then the second friend wanted 3 burgers, so 3b. And a drink, so they wrote D. Now, you can also write 1D, because 1 drink and a drink mean the same thing. And finally, why would the mathematician write minus 2B and minus 2D? Well, remember the first friend said, hey, actually take off 2 burgers, so subtract 2 burgers, and 2 drinks from the order, so subtract 2 drinks as well. So this is the expression that the mathematician would write for this story. Would it be a good idea for Jax to go up there and say, I want 5 burgers, 2 fries, 4 drinks, 3 burgers, 1 drink, and also take away 2 burgers and 2 drinks? No, I think that'd be really confusing. So what we're going to do is we are going to simplify this expression. So when we simplify the expression, and we're going to simplify by combining our like terms. So if you remember what like terms are, they are the same variables to the same power. So if you have a highlighter, it actually makes it really easy. We have 5 burgers first. Now, are there any other burgers in that order? Well, we also had plus 3 burgers and minus 2 burgers. So in our order, Jax was told to get 5 plus 3, and then you say, wait, take away 2 burgers. So 5 plus 3 is 8, minus 2. That is a total of 6 burgers, so 6B. So sometimes if you don't have a highlighter, some people like to circle. And then, circle the like terms. Now, is 6 burgers the only thing Jax is getting? No, he also had to get fries and drinks. So let's take a look at the fries and drinks. So if we had a pen, or actually if I'm using a highlighter, I should use a different highlighter for the drinks. Let's go with green. So 2 fries plus 2 fries. Any other fries in here? Let's see, 4D, nope, 1D, nope, minus 2D, nope, just 2 fries. So we're gonna say, all right, 6B plus 2F. Now, if you didn't have a highlighter, you may wanna use a different shape, like, oh, I can use a box for the fries, like rectangles for the fries. All right, are we done there? Just 6 burgers and 2 fries? No, because he also had to get some drinks, so it says, let's use a third highlighter color. We have 4 drinks, plus 1 drink, minus 2 drinks. Now notice when I highlight this, I'm also including the pluses and the minus in front of it because it kind of tells me whether I should add or subtract. So some people like to do like, let's do another shape like a triangle for all my drinks. So what's 4 drinks plus a drink minus 2 drinks? That's 4 plus 1 is 5 minus 2. That is 3 drinks. So can we simplify the mathematical expression and explain what it means? Yes, we can say 6 burgers plus 2 fries plus 3 drinks. That is the explanation. He's going to order 6 burgers, 2 fries, and 3 drinks. You could also say he's ordering 6 burgers and 3 drinks and 2 fries. It makes it doesn't really matter what the order is. You know, some mathematicians would say, oh, you got to do an alphabetical order, so burgers first, then drinks, then fries. But it really doesn't matter. Both mean the same thing. All right. Let's try some other problems which don't have stories about them. So the directions are to simplify each algebraic expression by combining the like terms if possible. So example 4, 5x, let's highlight that, 5x. Is there anything that, you know, is a like term with 5x? Yeah, we have 2x or plus 2x. So plus 2x. So what is x? Well, maybe x rays. 5 x rays and 2 x rays. Can I simplify that? Yeah, we can just say that's 7 x rays or 7x. And that's our answer. Let's see, number 2. We have a y and a y, so that's like a yogurt and another yogurt. What if I have a yogurt? Or, you know, remember that it's like a hidden 1. So that's like 1 yogurt plus 1 yogurt. Both like terms. So what do I end up with? I end up with 2 yogurts. Not yogurt square, or yogurt to the second power, but 2 yogurts. All right, next one. We have 11 x-rays. Any other x-rays? Yes, we have plus 4 x-rays. So that's all the x-rays. That's a total of 15 x-rays. What else do I have here? Well, I've got plus 3y, plus 3 yogurts. So that's 15 x-rays and 3 yogurts. And that is simplifying the expression because we're combining the x's, the like terms, and then there's nothing that I can combine 3y with, so I just add that on. Example 7. I've got 3n. Can I combine 3n? Any other n's? No, no other n's. So I'm just going 3n. And then over here I've got a 7. And there's nothing to combine that with, so I just write 3n plus 7. Remember, you are going to combine the like terms if it's possible, if we can simplify. Some people look at this and they feel like, oh my goodness, I have to do something to it. 3n plus 7 can't be the answer, so they just like do 3n. They just say, oh, that must be like 10n. That's not correct. They are not like terms, so you cannot combine them. Don't try to combine them if they can't be combined, all right? So you can just leave this answer as 3n plus 7. All right, number 8. Let's take a look. We have 10a. Pretend that's 10 apples. And any other a terms? Yeah, we have 2a, and there's a minus in front of it, so it's 10a minus 2a. Any other a's? Nope, that's it. So 10a minus 2a is 8a. That's like 8 apples. And then grab my other highlighter color, and then we have a 3, a plus 3. Oh, and it's by itself, so it's just 8a plus 3. Take a look at number 9. We have 12x. Whoops. 12x. Any other x terms? Ooh, we do have an x term. It's minus 2x. No other x terms. So 12x minus 2x, that is like 10x, or 10 x-rays. Let's take our highlighter again. We have plus 5. Oh, plus 5 is just by itself, so it's 10x plus 5. And that's our answer. And that's what happens when we simplify. All right, example 10. This gets a little bit weird because now we have a bunch of m's, but we also have like different powers. So let's start with 2m to the second power. Remember, it has to be the same variable to the same power. So can we combine that with 5m? No, because it needs to be m to the second power. So is there any other m's to the second power? There are. This is 8m to the second power, so 2m to the second power plus 8m to the second power. How many is that? That is 10m to the second power. What else do I have in my expression? I also have that minus 5m, so I need to include that in my answer, minus 5m. There's nothing to combine it with, so that's it. Let's take a look at the next one. We have x. I'm going to write a little 1 in front of it, just in case it's 1x. Any other x's in here? Ah, yes, 8x plus 8x. Any other just regular x's? Well, this is an x squared, and this is also an x squared, so we can't combine that. So let's combine our x's. We have 1x plus 8x, which is 9x. And then I also have plus 9x squared and minus 5x squared. Those are both like terms, so that's plus 9x squared minus 5x squared. What does that equal? That equals 9 minus 5, that is 4x squared. Now, is there you can also write your answer as 4x squared plus 9x, and they both mean the same thing. Which answer is more correct? Technically, you should write it in a certain order, but don't worry about it. They're both correct. This one is like later grades. They'll say this one is actually more correct. It's the better answer, but they both mean the same thing, so don't worry about it. All right, example 12 is kind of a weird one. We've got E, which I'm going to write a 1 in front of it. That's 1E. This is also 1E, so that's E. Any other E's? Yep, there's another 1E here. And there's another E over here. It's minus 2E. So what's 1E plus 1E? That's 2E. So 2E minus 2E. 2 minus 2, that's 0. You have 0 E's. What else do I have left in my expression? I also have plus E squared. So can I simplify this further? 0E plus E squared. What is 0E? Let's say E is an elephant. I have 0 elephants. Do I have to, can I just not say that I don't have 0? Can I just say E squared instead of 0E plus E squared? I can. Another way to think about it is what's 0 times E? It's 0. So what's 0 plus E squared? It's just E squared. So I don't really need to write 0E plus E squared. You can just simplify that further to just E squared. Like this 0E is kind of pointless. You don't need to include it. Okay? All right, number 13, 14, 15, only 3 more. So let's do 3a to the third power. Any a to the third powers? A cubed. This is a squared, b squared, b squared. Nope. So 3a to the third power. Let's do another highlighted color. Let's do blue. I have minus 7a squared. Any other 7a squared? Or sorry, not 7a squared. Any other a squares? No other a squares. This is b squared, and this is b squared. Different variable, so you cannot combine it. So that's just minus 7a squared. All right, let's do another highlighter color. 8b. Any other b? Sorry, 8b squared. So any other b squares? Yeah, we have 2b squared. So that's 8b squared plus 2b squared. That is a total of 10b squared. And that is our answer. All right, next one. We've got k squared. I'm going to write 1 in front of it. Any other k squares? K to the second powers? Yep, we got 9k squared. So that is 1k squared plus 9k squared, which gets us 10k squared. Let's do a different highlighter color. We have 6, and any other like terms that go along with 6. Any other constants? Yes, we have 6 and minus 2. What is 6 minus 2? That is 4. So 10 and 4. 10k squared plus 4. Last one. 9w squared. Any other w squared terms? Ah, here it is. Negative minus 5 squared, w squared. 8w and 5w do not count because they're not squared. So what's 9w squared minus 5w squared? That is 4w squared. Okay, any other terms left over? Yes, there is 8w. And any other w's? Yes, 8w and minus 5w. That is a total of 3w. So 8 minus 5 is 3. And we cannot simplify further, so 4w squared plus 3w. And that's our answer. So that's it. That is combining like terms. You're looking for terms with the same variables to the same power. And sometimes they're not going to have variables at all. It's just going to be a constant, like, you know, +5, or in this case, where is it? 6 and -2. They're just constants, and you can combine those as well. But go ahead and try some problems on your own. Good luck. Oh, come on, cancel.